Can you guess the missing word? This is exactly the kind of problem that large transformer-based language models can solve. They receive a piece of text called a prompt and guess the token that most naturally comes after it. Today, we'll show you how it is possible to handle basically any task in natural language processing with this simple interface. For example, if we want to generate a large text, we just need to repeat the process several times, adding the generated token to the prompt at each iteration. GPT-3 is a large language model with 175 billion parameters built into a convenient playground where users can try them out. Let's assume we want to write a recommendation letter for an employee. First, we make up the beginning of our letter and use it as a prompt. As you can see, when it comes to the recommendation letters that we generated, it isn't easy to tell whether it was made by a human or AI. What if our task is more complex than just generating text? Can we, for example, make a French to English machine translator? For this, we can use the technique called prompt engineering. First, we build up our prompt in a way that the natural continuation of the prompt will lead to the solution for our problem. For this machine translator, we will list numerous French and English sentences side by side, separated by an empty line, and then put the target French sentence at the end. Alternatively, we can also put translation from French to English at the very beginning so that the model has even more context to understand the problem. Does it all work? It actually does! A large language model, or LLM, is smart enough to understand our format and generate the desired result. This process is called few-show learning. By engineering the prompt in the right way, we managed to teach the model to solve our NLP problem on a relatively small number of examples. Let's look closer at how this LLM generates the next token. It predicts the probability for each token in the dictionary to come after the prompt, and then chooses the token with the highest probability. We can get access to these probabilities at each generation step. For example, an alternative to the word movie is film, and an alternative to among is with, so the article could have skipped this, and young could have been replaced with youth or youngsters. If at one generation step we choose the second option, the generation will then follow a completely different path. LLM user interfaces allow you to control the degree of randomness in model generation by the temperature parameter. The higher the temperature, the more often the model will generate tokens lower in the probability ranking. If we set the temperature to 1, then we can get different translations of the same French sentence. The more examples you provide to the model, the better it will perform on your specific task. However, the prompt size is limited. In the case of GPT-3, the limit is 496 tokens, so you can't always put as many examples as you want. If you need to boost the performance even more, you can fine-tune the model to solve your problem. Fine-tuning involves creating a copy of the model, then training it on an unlimited amount of data in your desired format by changing the model parameters. Let's take a look at an example. We have a fine-tuned model that generated docstring comments for Java source code. Here we have a binary search method. We hit submit and voila! We get a well-formatted comment for that method. Another example would be ChatGPT, which is a version of GPT-3 that was fine-tuned on large amounts of conversational data, so it can simulate human speech very well. ChatGPT was trained to act as a virtual assistant. The training data included a plethora of conversations, and it produced correct responses to various human requests. LLM capabilities are not limited to natural languages only. Github Copilot is a source code completion tool that is powered by Codex, which is a version of GPT-3 for programming code. You can try out large language models yourself. There is GPT-3 by OpenAI that is accessible through the Playground or through the simple API that you can call from Python. However, OpenAI charges a small amount of money for each request to GPT-3. There are free alternatives to GPT-3. For example, you can browse different LLMs on the HuggingFace website and then call them from Python using the Transformers library. Models from HuggingFace will run locally on your computer. However, unless you have a GPU mining farm at home, you can only run relatively small models, which will yield worse results. Large language models can also solve various business problems such as content creation, including document generation, suggesting text completions, and audio generation, document processing, including text correction, document formatting, text summarization, information extraction, searching documents, and text classification. Conversational AI, including chatbots or virtual assistants that can interact with users in a natural way and provide assistance or answer questions. Language tasks, including machine translation and text stylization. And source code-related tasks, such as generation, completion, correction, commenting, and searching. Overall, the potential applications for large language models in businesses are vast and are able to bring numerous benefits to the companies that utilize them. Good luck and have fun experimenting with large language models.